Very good. For our last slide, what we'd like to do is compute confidence intervals. And the confidence interval is one of the first of the inferential statistics that we will be covering in class. So the question we're asking is, what can we know about the population if we have some idea of what characteristics a sample has? And one of the first things we can compute about the population based on what we know about the sample is what we refer to is the mean, and the way we capture that is by a statistic called a confidence interval, or CI for short. Okay, there are a couple of things I want to show you or remind you about before we talk about the confidence interval. If you remember, I showed you this slide at the end of the last presentation. Notice that for the normal curve, the mean is always in the center. So if you go one standard deviation on either side of the mean, as represented in blue, you would capture 68.2% of the population. If you went 2 standard deviations away, this is reflected in the pink, you would capture 95.4% of the population. And if you went 3 standard deviations away from the mean, you will capture almost all, 99.7% of your population. It's this one here that's of interest to us at this point, the 95.4%. In reality, we're more concerned with capturing 95%, because we believe that if we capture 95% of all possibilities, that's an error that we can live with. So what we do then is look at what the standard deviation is if we were to capture 95% of a population, and it turns out that that standard deviation would be 1.96, pretty close to 2, but not quite. So why is that important? It's important because when we calculate the confidence interval, or when we calculate the mean of the population based on the sample, we need to know what the 95% confidence interval, the 95% standard deviation is. So here's a formula that we use to calculate the confidence interval. We need the mean of the sample. We need a level of confidence, which is 0.05. This is actually the reverse of 95%, and that's reflected in the third piece, that the z-score includes 95% of the sample. And we need a standard error. Let me go back and show you something here. When we computed information on the highest year of school completed in the previous presentation, I asked you to calculate the standard error of the mean. And so if you go back to that computation, you will notice that the standard error of the mean is, for education, highest years of school completed, is 0.069. That's important to us because that is part of what we need to calculate the confidence interval. Let's break this down into its component parts then. This is the mean of the sample. This is plus or minus. Your handouts would have just a plus, but it should be plus/minus, which is plus or minus 1.96 times that standard error, that statistic I shared with you a second ago. So then, if we were to calculate the confidence interval for education, we can go back to the information on education, and you'll notice we have the mean, we have the standard error, and we now have a constant called 1.96, which is the 95% of all scores. So let us put that into this formula that we just generated, that x bar plus or minus 1.96 times the standard error of the mean. I know I wrote this as x bar, but there's no easy way for me to do that in this software that I'm using, and that's why I wrote the words out x bar to represent the mean. So let's plug in those numbers. If you recall, the mean was 13.43 plus, or, well, that's not a plus, that should be plus or minus 1.96 times, and the standard error was 0.069, so we'll plug that in our formula, and if you work that out you will get 13.43, and we'll do the plus first, plus, and if we worked out the 1.96 times 0.069, we'll get 0.13524, and that will be equal to 13.56554, which I'm going to round off to 13.57. I'm going to do that. So this is the first answer, and that's because this question is two parts. It's a plus or a minus, so we have to compute both. And so the second part, 13.43 minus 0.13524, and that would leave us with 13.29429476, which we will round off to 13.30. So this is our second. Okay, so then what we are sure of, 13.302, 13.57. So then what we are sure of is, let me not do that, what we are sure of is that the mean of the population from which these 2018 answers were gotten for this sample, the actual mean of the population, if you were to take every single person in the population and ask the question what is their highest level of education, it will be somewhere between 13.3 to 13.57 years. So that is the way we compute the confidence interval. So here is a check for you. Why don't you see if you could do the same thing, compute the confidence interval for the other variable that I had asked you, age of respondent. Alright, there are a couple other things that's a part of this lesson that we can cover later on, but I think that we've covered the essential pieces that will be helpful in getting you to move forward. Alright, take care.